Introduction to BTX distillation process. Before we dive in, let us know first what is distillation process. Distillation is the process of separating mixtures of liquid by their different boiling point. So, question given is demonstrate a design process to recover 98% toluene from 1000 kg per second of mixture containing 20% benzene, 30% toluene and the remaining xylene, which is 50% using distillation columns in series. Chemical compounds that are involved: first, benzene. This has a molecular formula of C6H6 and boiling point of 80 degrees Celsius. Second, toluene, molecular formula of C7H8. Its boiling point is 110.6 degrees Celsius. And the third, xylene, which has a molecular formula of C8H10 and its boiling point is 143 to 145 degrees Celsius, the highest. Okay, so our design process are called BTX distillation process.
Our distillation sequence for the separation of benzene, toluene and xylene will be in direct sequence, in which the bottom product stream of the first distillation column will be the feed to the second distillation column. According to Thermopedia, most common column diameter is about 2.5 meter and column height is about 30 meter. For the assumption of pressure is constant at 1 atm throughout the whole distillation process. Distillation at steady state has a fixed pressure and only temperature is changed to regulate the composition of the product stream. Lower pressure requires less energy to be added into the boiler for separation and increases the vaporization.
Hi, my name is Ashu Emma and I'll explain about purity, recovery and block diagram in my part. First of all, purity is the ratio of named pure substance in a sample by weight, mass, volume or count. A number between 0 and 1 typically expressed as percent per mil and fraction. In this process, 99.5% purity of benzene is assumed, which indicates that 99.5% of benzene of the mass flow rate will be formed in the top product stream, while 0.05% of the impurities are contained in the benzene product. Percent recovery computes the percentage of an original substance that is recovered after a chemical reaction is completed. These mainly include purification reactions. It also determines the efficiency. According to BTX extraction technology article, typical recovery of benzene and toluene at least 99% and 97% respectively. To have higher recovery, slightly more energy is needed. In this BTX distillation process, 99% of benzene recovery and 98% of toluene recovery are assumed, meaning 99% of the benzene and 98% of toluene in the feed will be converted into the product stream. This process is in steady state and it is a non-reactive system. The heavy component is preferable to remain as liquid in the bottom product stream, while the light component is required to remain as vapor in the top product stream. The typical temperature profile will be hotter at the bottom due to the reboiler, while cooler at the top due to the condenser. From this design, we have benzene as a lighter component with the boiling point of 80 degrees Celsius, toluene with a boiling point of 110.6 degrees Celsius and xylene with a boiling point of 139 degrees Celsius. The assumptions for temperature is based on the boiling point of the components. So from the first distillation column, we can see that the temperature is 90 degrees Celsius on the top stream to ensure major amount of benzene, 99% will be distilled and become vapor in M2. Minor amount of toluene will change into vapor phase in the top product stream. Xylene, which have higher boiling point than benzene, remain as liquid in the bottom product since the boiling point is not achieved. Temperature for the bottom stream is slightly higher than the top stream, which is assumed to be 95 degrees Celsius. Next, we have the second distillation column in which more heat is added to increase the temperature. The temperature is 115 degrees Celsius in the top product stream. In this column, both benzene and toluene will be the top product M5 since its boiling point is lower than the fixed temperature and will turn into vapor phase. At the same time, minor xylene will be distilled at the top product due to cohesion forces between molecules of benzene and toluene. Major xylene as heavier component will remain as liquid at the bottom as xylene have higher boiling point than the column, which is 139 degrees Celsius. Temperature for the bottom stream is slightly higher than the top stream, which is assumed to be 120 degrees Celsius.
Now, let us move to the calculation part. In this part, the concept will applies the law of conservation of mass. According to this law, it states that for any process unit, mass can be neither be destroyed nor created, but it can change from one phase to another phase or converted into other forms through reaction process. Hence, it can be concluded that the total mass input will be equal to the total mass output. There are 5 assumptions they have made in order to solve the question given. First and foremost, the purity of benzene and toluene are assumed to be 0.995 and 0.98 respectively. Besides that, we also assume the recovery rate of benzene and toluene to be 99% and 98% respectively. In addition, the process is assumed as a non-reactive system and is at a steady state. Therefore, the accumulation equals to 0 as well as there is no consumption and generation. The input will be equal to the output. the process flowchart. Letter B, T, and X represent benzene, toluene, and xylene respectively. M with a dot above is the mass flow rate of each stream, and the mass fraction of each component is stated below the stream. The condenser and the boiler are neglected in the calculation part. Before we solve the question, let's calculate the degree of freedom. For the first distillation column, there are 5 unknowns in total along with 5 independent equations. Therefore, the DOF equals to 0. For the second distillation column, there are 10 unknowns, but there are only 7 independent equations that we can come up with. So the DOF is equal to 3. Now, let's start with the distillation column with 0 DOF, which is benzene distillation column. From the fourth equation, we can get a value of M2 which equals to 108.99 kg per second. Then from the first equation, we can know that M3 is equals to 801.01 kg per second. After that, Z can be calculated which equals to 0.6242. Since the values of M2 and M3 are known, we can calculate Y using the second equation, so Y equals to 0.3733. Lastly, since X plus Y plus Z equals to 1, so X equals to 0.0025. Now, let's continue with the second distillation column. Since we knew the values of Y and M3, we can calculate M4 using the fifth equation. Then from the overall mass balance equation, we can get a value of M5 which equals to 501.99 kg per second. After that, the value of P is calculated using the second equation. Since 0.98 plus P plus Q equal to 1, we can get the value of Q which equals to 0.0133. Then from the third equation, the value of T can be obtained which is equal to 0.981. Lastly, we can also calculate the value of C that is equal to 0.0119. Since all the unknown values have been calculated, a complete flowchart can be obtained. By multiplying the purity of toluene and the mass flow rate of the top product stream of the second distillation column, we can know the amount of toluene which equals to 293.04 kg per second.